Okay, first something I tell you about myself. My name is Sunil Awasthi, working as an assistant professor in Faculty of Engineering and Technology, Rama University. Now, in today's lecture, I will explain you how we can communicate our Java application with the database. Okay, so suppose we have developed a Java application which is built in Java programming language, and we want to communicate our Java application with the databases. Various types of databases RDBs are available in our today market, like Oracle, DB2, MySQL, SQL Server. Lot of databases are there. So if we want to communicate our Java application with database, certain things we have to do. Okay. So what my objective is, I have a Java application, I have also a RDBS like Oracle or DB2 etc. And what I want that I can able to communicate my Java application with this databases. This is what we want, actually we want. So this can be done using JDBC API. JDBC API. JDBC stands for Java Database Connectivity. This is the JDBC API which is provided us by the Java vendors, Sun Microsystems. Okay, they provide us JDBC API by which we can communicate or which we can handle databases through our Java application. Okay. One more thing we want to know, that there are various types of Java applications like standalone applications, web applications, distributed applications. There are variety of applications which we can build by using Java programming language. Okay. So in actually mainly Java is in three flavors. One is J2SE or JSE. Second one is J2ME or simple JME sometimes, and J2EE or JEE sometimes. Java to standard edition or Java standard edition, Java to micro edition, Java micro edition, or Java to enterprise edition or Java enterprise edition. Okay. JDBC is the part of the J2EC itself. It is the part of the JDBC is the part of the J2SE or JSE. It means if I develop a Java application, means standalone application, we can communicate standard applications with the RDBs, as well as if I develop a web application using Java, even then I am able to communicate with the databases by using JDBC. Okay. This one is the JDBC architecture. What is this? Here there are three RDBs: Oracle, MySQL and DB2, maybe more, and this is your Java application. Your Java application can have to communicate with these databases. So what is the architecture it follows? By using JDBC, you can communicate with these databases. What are these? Oracle driver. For Oracle there is Oracle driver, MySQL is a MySQL driver, this is DB2 driver. Means every database vendor must provide you a software called driver software. Okay. Every database vendor will provide you what? A driver software. By using this driver software, your Java application or your application are able to communicate with the databases. Only by using or the use of this driver software, your Java application is able to communicate with the database. And who provide these drivers? Corresponding database vendors. Corresponding data vendors will be provide these driver softwares. Okay. What are the driver softwares? They are provided by the database vendors, and they make your program able to interact with the corresponding databases. A very important class named as driver manager. It is in your SQL package, java.sql package. There is a class named driver manager. This is a very important class which makes your program able to interact with these drivers. So what is the scene? That By using this driver manager class can interact with these drivers, and further these drivers can communicate with the corresponding databases. So, driver manager class is in which package? Java.sql package. Okay. I think that you are aware about the what is the packages. Packages are simply the collection of classes and interfaces. What are the packages in Java? In Java, packages are the collection of related classes and interfaces. Okay. So, here is my Java application, and by using this JDBC, I have to interact with database through this database drivers. Okay. And what is the database driver? It is a software, simply it is a collection of programs. Database driver software are simply collection of programs in which a specific class is called driver class, which drive the software. That is why it is called driver classes. All the drivers currently in the market are categorized mainly into 4 types: type 1 driver, type 2 driver, type 3 driver and type 4 driver. Type 1 driver is also called bridge driver or JDBC ODBC bridge driver, simply bridge driver or JDBC ODBC bridge driver, type 1 drivers. Type 2 drivers are also called native drivers. Type 3 drivers are also called middleware drivers, and type 4 are also called thin driver or pure drivers. Okay. Okay, now we are going to see one by one. Type 1 driver, this is the architecture of the type 1 driver. This is the client side, means at client machine these are required, and this is your database. This is your Java application and this is your database. Okay. And I want to communicate my Java application with this database by using which type of drivers? Type 1 driver. So, here again I have to use a product of Microsoft product, that was ODBC, introduced in 1992, ODBC Open Database Connectivity. When if I use Windows operating system, automatically it is available to us. Okay. Here is my Java application, and I am going to use this JDBC ODBC bridge driver. It is already come with the J2SE. It is automatically provided us by the Sun Microsystems or Java vendor, JDBC ODBC bridge driver. We have not to use it or install it separately. First thing, it is very easy because we have not to install it separately, so it is very easy to use it. So, at client side we need 3 things: my Java application, JDBC bridge driver, which is automatically in our application, available to our application, and ODBC. If I using Windows operating system, it is also available, and that one is databases. So, what happens here? First, our Java calls change to ODBC calls by using which driver? JDBC ODBC driver. JDBC ODBC bridge driver transforms or changes our Java calls into ODBC calls. First transformation. Then ODBC calls into which converts into databases calls. So, there are 2 transformation here. The first, Java calls changes into ODBC calls by which driver? JDBC ODBC bridge driver. Then ODBC calls changes into corresponding database calls. Again, when response come, then database calls changes into ODBC calls, first transformation, then ODBC calls changes into Java application calls. So, you see that there are 2 transformation, first here, then ODBC to database. That is why it is slowest of all other drivers, means performance wise it is least, it is worst. If I compare it with other drivers like type 2, type 3 or type 4, its performance is least. The slowest of all the drivers, also called snail drivers. That is why, because it is slowest, that is why it is called snail drivers. Okay. Performance wise very poor, and the main thing is it is database independent. Why? Because you can see that Java application is not directly interacting with the database. After some time, if suppose instead of using Oracle, suppose at moment I am using Oracle, and after some time I will move to MySQL, suppose, then I have to do no change in my Java application. Automatically ODBC will handle this. So, our Java application is database independent. If I am using which driver, JDBC ODBC drive, type 1 driver, then my Java application is database independent, but it is platform dependent. What is the platform dependent? It means with only Windows operating system we can use this driver, because internally this driver have to interact with what? ODBC, and it is the part of the Windows operating system. So if we go for this driver, then definitely I have to use ODBC, and which is the part of the Windows operating system. That's why it is called platform dependent. So now I conclude that type 1 driver or bridge driver is database independent but platform dependent. Okay. Now this is type 2 driver. This is all about the type 2 driver. First, its architecture. Again, you can see that it is very similar to type 1 driver due to with some changes. Here ODBC changes into database specific native libraries, and type 1 driver changes into type 2 driver. Again, what are database specific native libraries? These are the libraries, or mainly these are the collection of simply functions which are written in C or C++. They can directly understandable by the databases. So they are database dependent. Again, see, native libraries are database dependent and mostly written in C or C++. Again, and what happens here? Our Java calls changes into database specific native libraries calls. Java calls changes into native libraries specific calls which are understandable by the databases. So what type 2 driver or native driver works here is to change our Java calls into native libraries specific calls which are understandable by the corresponding databases. So performance wise it is better in compared to type 1, because only one conversion is required. Okay. So whereas in type 1 there are two conversions. You remember that? First Java calls changes into ODBC calls, and then ODBC calls changes into database specific calls. Okay. But here Java calls changes into native libraries calls which are directly understandable by the databases. So by performance it is better in compared to type 1, first thing. Second thing, uses database specific native libraries at client end. Means at client end you have to install database specific libraries of the corresponding database to whom you want to communicate. Okay. And it is database dependent. Why it is database dependent? Because suppose, because you know that this is database dependent, these libraries are dependent to databases. So after some time if you want to move from one database to another database, then you have to install that database corresponding libraries here. Okay. So it is database dependent. It is also platform dependent. Why it is platform dependent? Because mostly these are written in C or C++ which are platform dependent languages. So automatically your whole application becomes also platform dependent. So type 2 driver is the only driver which has both, means it is data dependent, database dependent as well as platform dependent also. It is architecture of the type 3 driver. Here you can see that at client side two things are required, your Java application and your driver. It is a 3-tier architecture. It has 3-tier architecture. First tier is client side, second tier is middleware server which is a third party mostly, and third tier is database. It has 3-tier architecture: client side, middleware server and database. In this a third party or middleware server is required mostly, and most of the time IDS server, internet server. Okay. What happens here? Your Java calls first changes into middleware server calls, middleware server specific calls. Your type 3 driver changes your Java calls into first transforms it into middleware server specific calls. Then this middleware server specific calls changes into database specific calls. Further, this middleware server further uses either type 1, either type 2 or type 4 type of drivers to communicate with the database. But at client end you have not to worry about this, because it is all the headache of this middleware server. Okay. So in here you can see that again If after some time I want to change my databases, then it is all about to middleware server, because middleware server has to change how to it has to be communicate with the new database. Okay. In client side, there will be no change in your Java application. It means it is database independent. First thing, Java application becomes database independent because it has to interact only with the middleware server. It is not directly interacting with the database. It is not directly interacting with the database. It has to interact only with the middleware server. Okay. So it is database independent. It is also platform independent because type 3 driver is purely built on Java language. Type 3 driver purely built in Java language, which is platform independent. It means your whole Java application also becomes platform independent, and database, it is also database independent. It means it is the only driver which is both, means it is database independent and it is also platform independent, whereas type 2 driver, it is platform dependent as well as database dependent, but type 3 driver is database independent as well as platform independent also. So its performance is very good, and if there is no specific requirement, then always use type 3 driver. Okay. This is the last type of driver. This is type 4 driver. Type 4 driver uses database specific protocols, which is directly understandable by the database. Type 4 driver uses database specific network protocols which are directly understandable by the databases. So type 4 driver directly transforms your Java calls into database specific calls and database specific calls into Java calls. It means only one conversion is needed, not as like type 1 or type 3. Okay. So performance wise it is best, it is very good by performance wise. Okay. And this type 4 driver is purely built with the Java language, so it is platform independent. That's why it is also platform independent. So it is here you can see that it is platform independent because it is purely developed on Java, which is a platform independent language. That's why it is a platform independent language, but it is database dependent, because again directly your Java calls changes into what? Database specific. So after some time, if you want to change database, then again there is a separate requirement for the driver. Okay. So if you do not have requirement of changing database in future, the condition is if you do not have requirement of changing database further, then it is best to use which type of driver? Type 4 driver. Okay. And there is only one layer of conversion, that's why it is also called thin driver, because there is only one conversion, means directly Java application or Java calls changes into database specific calls. That's why it is also called, only one conversion is done. That's why this is also called thin driver. It is also called thin driver or single layer, because of single layer, and it is purely built on Java. That's why it is also called pure Java driver or pure driver. Okay. So this is all about the drivers, their architectures. Type 1, type 2, type 3, type 4 drivers are there and their corresponding drivers. So according to our requirement, we have to use appropriate driver, whether go for type 1, type 2, type 3 and type 4. Again type 1 is supported only till 1.7 version of Java, and from 1.8 it is not available to us. Okay. Thank you.